The basics to shear force and bending moment diagram is the equation of understanding the equation of forces and moments. For example, if we have a simply supported beam like this, reaction at both points A and B, and then there is a force applied here in the middle, P. In this case, it's a constant force. So force is basically a constant value, constant force. If we want to plot this in a graph, it's gonna look like something like this. So a constant. So P equals constant when the y-axis is the P or force. We use P symbol for force, and then x-axis is the x value distance. If we have a force instead of a constant force, we can say, for example, a distributed load. So this is a simply supported beam, and then we have a distributed load of, let's say, omega pound per feet. So every foot of this beam, I got x foot of beam, omega amount of force. So total force can be calculated omega times x. Total force. Now this force is not a constant, it's more like a y equal mx plus mx type of equation. So I got x and then y is the P, and then it's a line through the origin. So this equation is y equal mx, or we can compare that like this. Since in this case is P equal to omega x. Now if we see what happened to moment, we know that moment is equal to force times distance. Moment is force times distance. So in this case, moment is equal to force is P, and then distance, let's say x. So now you see this same situation when moment was a 0-degree curve. What I mean by 0-degree curve is basically constant times x power 0, which is basically 1 x power 0, and where this moment becomes 1 degree more because of the distance multiplied by the distance. So moment curve is 1 degree higher than the force curve. So for a constant value of force become moment something like this. This would be moment equal px. So this y is the x, and then y is the moment here. Same here, we got P equal omega x squared. So if we want to calculate, it's gonna be some constant, we don't know what that is, let's say a, and then x is squared. So curve become now second degree because this x is multiplied by distance x, which x is squared. So then this curve looks something like a parabola, like this, m equals a x squared. So that way x and then moment y axis. So what I'm trying to explain here is if moment is a whatever the degrees of the force, the moment will be 1 degree more, and also once we know the degree, we could draw or predict how the curve look like when we solve shear force and bending moment diagram.